Hi everyone, my name is Kathy, and today I'm going to work on a chemistry problem with you. So let me go ahead and share my screen because I like to use my iPad when I'm solving problems. It just gives me more flexibility in writing. So the problem that we're trying to solve is, and I'm going to go ahead and just write it out here, what is the momentum of an electron traveling at 68% of the speed of light and what is the wavelength in nanometers. Now you can see I used a couple of abbreviations, so I just want to go through them one more time. P is the abbreviation that we use for momentum. And this symbol here is lambda. It's actually the Greek letter L, and that is what we're going to be using for wavelength. Okay, so let's go ahead and solve our first problem. And to do that, what I'm going to do first is list the information given and any other information I might need. So it says, what is the momentum? So I'm going to go ahead and write, that's what we're looking for, of an electron traveling at 68% the speed of light. So that tells me that the velocity is 0.68 c, where c represents the speed of light. And you can look up that value. It's typically listed as 3.0 times 10 to the 8th meters per second. Now, I know that momentum is mass times velocity. So what I also need is the mass of the electron, and that you can also look up. You're going to want that in kilograms, so that would be 9.109 times 10 to the minus 31 kilograms. Okay, now I have everything I need to find the momentum. It's just plug and solve. So here we go. Momentum is the mass. We'll go ahead and type 9.109 times 10 to the minus 31. And the velocity is 0.68 the speed of light. And we break out our calculator and plug in those numbers, and we get to this value here. Now I'm going to go ahead and write out all of the digits, and then we will round to sig figs. Let's see, did I lose any there? No, I think I got them all. Okay, and our unit, right? So our unit is kilograms and meters per second. So it's going to be kilograms meters per second. Now I need the unrounded value for my next calculation, but if you're looking for the rounded value, right, we're going to need to do sig figs. And we're doing multiplication. So for multiplication, we take the fewest number of sig figs. This here has 4, 2, and 2. So my answer would round to 2 sig figs. So I'm going to go ahead and just write that 1.9 times 10 to the minus 22 kilograms meters per second. That is the answer to the first question. So let's go ahead and solve the next question. And that is, what is the wavelength in nanometers? To find the wavelength, we're going to need another equation. I'm going to go ahead and switch colors here so we can kind of keep track of everything. So wavelength, we're going to need to use this equation. That is h over momentum. So you might be asking yourself now, well, what is h? H is a constant. It is called Planck's constant. So it's another value that you can just look up. And so h is going to be equal to 6.626 times 10 to the minus 34 joules per second. So you can see I have what I need now. I have Planck's constant and I have the momentum. And once again, I'm going to plug in my unrounded value into my wavelength equation. So let's go ahead and plug in. So h is 6.626 times 10 to the minus 34. Wavelength unrounded was 1.858236 times 10 to the minus 22. And this is going to give us the wavelength in meters. So that is 3.5 0.5657473 times 10 to the minus 12 meters. Once again, this question is asking for us to give the wavelength in nanometers. And we know that 1 nanometer is 1 times 10 to the minus 9 meters. So to find my answer in nanometers, I just need to divide my answer in meters by this value. So I'm going to go ahead and just scroll up here so we have a little more room. So let's go ahead and do that. So 3.5657473 times 10 to the minus 12 meters divided by 1 times 10 to the minus 9. And the unit there would be meters per nanometers. And we can see that that's going to give us 0.00356574773 nanometers. Now again, that is the wavelength and it is unrounded, right? So if we want to do the final answer, we will need to use significant figures. And you can go ahead and round that to the correct number of sig figs, but this is how you would solve the problem. So I hope this helps, and I look forward to maybe seeing some of you in class. Have a great day.